Okay, so here's our Unit 5 FRQ number 2. Here it says we have the rate at which water flows out of a pipe in gallons per hour is given by a differential function R of time t. The table above shows the rate as measured every 3 hours for a 24-hour period. Again, keyword here is rate, so therefore we know that this represents derivative information. It says use a midpoint Riemann sum with 4 subdivisions of equal length to approximate the integral r of t dt from 0 to 24. Using correct units, explain the meaning of your answer in terms of water flow. Okay, so this is, again, the data here. This table of information is the rate at which water is flowing out of a pipe. So, midpoint Riemann sum of 4 subdivisions of equal length. So, here we go. We go from 0 to 24, and as always, your setup is so very important. R of t dt equals. Okay, so let's talk about our 4 subintervals. We have to divide this information into 4 subintervals using a midpoint. It says using a midpoint. So let's see. Here's one interval, 0 to 6, 6 to 12, 12 to 18, and 18 to 24. So yes, we can get 4 subintervals using a midpoint approach. Now, remember, with this, we have to determine what the width is, and that goes from 0 to 6, 6 to 12. So our width, remember, is 6, and we need to multiply this by the sum of the heights of the midpoints. So the midpoint of the first interval is 3, and its value is 10.4, plus the midpoint is 9 on the second interval. Its height is 11.2. Then at 15, the third midpoint would be, the height would be 11.3. And then the last midpoint is 21. And that height is 19. No, it's not. It's 10.2, sorry. So 10.2. So now when we add this up, you get 6 times, I believe this will all add up to be 43.1. And when you multiply that, you get 258.6. And so we found the Riemann sum using midpoints to be 258.6. And it also says using correct units, explain the meaning. Okay, so if our information in our table was a rate and we found the value of the integral of r of t dt from 0 to 24 using a midpoint Riemann sum, remember this is area under a curve, but in context of the problem, since this was the rate at which water is flowing out of the pipe, then this is going to be that number is going to represent the total number of gallons of water that flowed out of the pipe during that 24-hour period. So, 258.6 gallons, there's your units, of water flowed out of the pipe during the t is greater than or is equal to 0 and less than or equal to 24, and that is in hours. So there's your there is your answer with the explanation using units. Okay, so now the B part, let me scoot this up. The B part says, is there some time, 0 to 24, such that R of t, R prime of t that is, equals 0? Okay, so since let's see what we have here. So R of 0, this is referring to the mean value theorem. And so since, what do we know about R of 0? The rate at which the water is flowing in is 9.6 gallons per hour, and R of 24 is equal to 9.6. Since R of 0 is 9.6, the rate at which the water is flowing out of the pipe at time t equals 0, and R of 24 is also 9.6, the mean value theorem guarantees that there is a time t on the interval 0 to 24 such that R prime of t equals 0. So that is stating the mean value theorem, guaranteeing that there is a time between 0 and 24 such that R prime is equal to 0. Okay? And that is because R of 0 equals 9.6 and R of 24 equals 9.6. So, that's FRQ number 2.